Here we have more proofs. So far we haven't seen a picture that looks like this one, but this is a very, very common picture for when we're doing proofs. This picture I always refer to as like a bow tie picture because it looks like sort of like a bow tie. In this picture that looks like a bow tie, you have touching triangles. That's generally the first thing that I mention when I'm looking at this picture. Touching triangles like this have vertical angles in the middle. I'm going to mark my angles in the middle congruent, even though I haven't looked at anything else yet. I just want you to notice this every time you see this kind of picture. So this will be important for our proof when we get there. Now let's look at our given. We're given that B is the midpoint of AE, and we're given that B is the midpoint of CD. So we need to list these into our proof, and we need to put given for our reason. And if I was making this proof from scratch, I could just list both of these in the first statement and put given as the reason. I don't have to separate them like they did in this proof. Let's fill these in. So B is the midpoint of AE, that's given. And then B is the midpoint of CD, that's given. These are free answers. You could have put them on the first two lines. You could have put them together on the first line. They split them up. That's kind of cool. Makes you look smarter. You have more writing in here. It's sort of spread out better. Now what they did was they used the definition of midpoint. Remember that if any time you have a vocabulary word in your given, you're going to have a reason that's either the definition of it or whatever that is, postulate, or whatever this word is, theorem. Just think to yourself, which one sounds the right way? Because really that's usually the correct one. Because you will have heard it enough in class to know, is it supposed to be a theorem? Is it supposed to be a definition? Is it supposed to be a postulate? I'm not real picky about if it's a postulate or a theorem if you put the wrong word. But for this one, we know that midpoint is just a vocabulary term. So the reason is definition of midpoint for these two blanks. So we need to think about what this midpoint definition is telling me. In this line, it says that B is the midpoint of AE. So I need to find AE. So here is AE. If B is the midpoint on AE, that means that to each side of B is an equal segment. So this side is equal to this side. And that's what goes into the statement. AB is congruent to BE by the definition of midpoint. So this is one set of sides in this triangle. I'm going to put a little S over here. You can put it off to the side. Knowing that I have put a side from my triangles into the proof. This way you'll keep tabs on did you list everything that you want to list in your proof before you say that the triangles are congruent. The next piece of given information is that B is the midpoint of CD. So let's find CD. Here's CD. If B is the midpoint of CD, then that means that to each side of B is a congruent segment. Since I've already used one mark, I'm going to use two here. So now I can list these pieces into the proof. DB, segment DB, congruent to segment BC by the definition midpoint. This is another set of sides. Number 5 says angle ABD congruent to angle EBC. Well, let's locate those and see what they're talking about. ABD, like connect the dots. Start at A, go to B, go to D. Start at A, go to B, go to D. Oh, that's this angle that I marked right here. Then EBC, E to B to C. That's this angle. We already marked those. And if you remember why we marked them, was that they were vertical angles. Now, when you write this in a proof, you absolutely have to put vertical, you can put vert, angles, and you must put that they're congruent. Because when I grade a proof, I have to act like I have no idea what you're talking about. And so you need to put congruent here so I know what about vertical angles. Maybe I don't know anything about vertical angles, so you have to tell me vertical angles, congruent. Or even are congruent would be even better. So vertical angles are congruent. This is an angle that is in my picture. Now, I don't want you to think that the last reason here is going to be these letters in this order. This just makes sure you have 3 things in your proof. We've got 2 sides and an angle in the proof. We should be able to prove that these triangles are congruent. So let's look at the picture to tell what order we need to write the letters in. We've got two sides that surround this angle. These two sides surround this angle. Since the angle is surrounded by the sides, then it is in the middle. So you need to list your sides with the angle in the middle. Side, angle, side would be the reason why the triangles are congruent. Let's look at one more proof. Here we're proving triangles congruent again, still doing that same thing. We're going to complete the proof, and they gave us the statements again. They are saying here that AB is parallel to CD. Parallel lines will always lead to congruent angles. Keep that in mind whenever you're given parallel lines. We're also given that AB is congruent to CD, and they marked it in the picture. So let's find our given in the proof here and put given for a reason. AB congruent to C, there we go, given. Now since these lines are parallel, I want you to look in this picture and see what angles you can get from that. There's no exterior angles here, so I need to think about interior angles from when we learned about parallel lines. Congruent angles that were interior were alternate interior angles, so let's see if we can find those. If I'm looking at this parallel line, see the Z shape that this forms? This means that this angle up here is congruent to this angle down here. This is the transversal that they're connected by. Remember that the angle needs to be touching the parallel line on each part so that you're not marking the wrong one. Now they labeled it for us, which is nice, ABC, DCB, so we know we got the right angles marked. These are congruent by the alternate interior angles theorem, which we learned about in Unit 1B. So that should be pretty fresh on your mind. Now let's look at the picture again. These triangles are touching. They share a side. I've already got one marking for congruent there, so I need to use two markings on the shared side. Remember that a shared side is always reflexive for the reason in your proof. So let's find it. CB, CB. It's the same thing on both sides. That's reflexive property for the reason. And now let's look at our picture. We've got a side, we've got a side, we've got an angle. They're all in the proof here. I've got my angle, I've got my two sides. So I am ready to say the triangles are congruent. Looking in the picture, notice where the angle is at. It is between the sides surround it. So the reason here will be side, angle, side, with the sides surrounding your angle.